Let me ask you this. Do you think that you see the world as it is? When you look at something, when you look outside, do you think that what you see is what is actually there? Let me give you an example. Look at this figure. Look at these two tables. How would you describe them? In fact, if you were to take the table on the left and lift it and put it on top of the table on the right, how would it look? Probably what you envision is that this table here is fairly rectangular, kind of thin and long, whereas this table is close to be a square. So if you took this table and rotated it and put it over here, I imagine this table here would kind of be longer than this table right here. And my guess is that you share this kind of view. Let me show you how that is actually not the case. Here, let me add a contour to that, just so that it's clear. And I promise what I'm about to do is totally real. There's no Photoshop involved. In fact, even though the two tables look so different, the tabletop is exactly the same size. And I promise it's not an illusion. I'm not changing anything. The tabletop in these two images is identical. What's happening is that even though this is a two-dimensional drawings, because we live in a three-dimensional world, your visual system is just automatically interpreting this image according to the rules of a three-dimensional world. And we will get into this in more detail once we start talking about how vision works. But the idea is that just because of the layout, just because of how the feet of the two tables are, your brain is reconstructing a perspective, is reconstructing the depth dimension. You should know that your retina is two-dimensional. So your retina takes a three-dimensional world, turns it in two-dimension, or rather filters it as a two-dimensional projection because your retina in your eyes are flat. And then your brain has to reconstruct, given the two-dimensional representation on the retina, how the three-dimensional world actually is. Now, in order to reconstruct depth, which your retina cannot encode, your brain uses a number of cues, and I'll show you a couple more just as examples. But as I said, we will discuss this in more detail another time. One of the cues is that your brain uses perspective to try to figure out depth. And this usually works pretty well because we do live in a three-dimensional world. But sometimes with these clever illusions, you can expose these shortcuts and these strategies that your brain uses. Let me give you another example along similar lines. Look at this construction right here. Look at this this object. If I were to take a ball and put it at the top here and push it a little bit along, in either of these four directions, what would you expect it to do? My sense is that you look at this and you think that, for example, if I took it here and I pushed it this way, it would roll down. And in fact, if I pushed the little ball from up here in any of these four directions, it would always roll from here down. In other words, just by looking at this way, you are thinking that these are four slides, with this being the top and the 4 slides slanting down. Let's see what actually happens. Turns out, either this is magic or you and me were very wrong. Turns out, as you're going to see now, this was another case of the perspective being a little bit tricky and exposing how the brain reconstructs 3 dimensions from only 2 dimensions. Okay, let's keep going. And I'm showing these examples not to show that you are wrong or that your and my brain is wrong. I'm just showing these examples to give you an understanding of how beautiful a machinery our mind and our brain is. Let me ask you this. Look at the 2 center squares on each of the 2 sides, this side and that side. So this square and this square right here. What color are they? My sense, from having asked this again in prior classes, is that this one here is some kind of, people typically describe this as yellowish or maybe orange brown, perhaps, something like that, but sort of a light brown or some kind of orange, something in that range. This one up here, on the other hand, very decidedly brown. Is that right? My guess is that this is exactly what you are perceiving. But is that what is actually out there? Turns out, if you get rid of everything around these 2 squares, so this one here is brown, this one here is actually the exact same color of that square. Here, let me do this again. Orange, brown, orange, brown. And I promise there's no trick. I'm not using Photoshop in any coy way. In fact, you can take my slides and you can do this yourself and see if this is real or not. See, what's happening here is something very interesting. We refer to this as color constancy. The idea is that your brain uses information from the context to understand, to infer what the real colors are. See, what's happening here is that because of the pattern of shading, your brain sees these colors as being exposed in the light. And so it turns them automatically a little bit darker than they actually are, because of course it realizes there's light there. And then it takes the colors that are in the shadow and it infers that these colors in reality are brighter than what your retina is seeing. But because there's the shadow, they appear darker than what they really are. So as a consequence, this brown tile here appears to you as being orange, as being brighter than it actually is. And that's because your brain sees all this shadow right here and says, ooh, all these tiles on this side are in a shadow. So they look darker than what they actually are. So even though this tile is brown, because there's a shadow there, your brain automatically turns it into a lighter shade. It's very adaptive. You want your brain to be doing this. You want your mind to be doing this. You wouldn't want that, you take a piece of fruit and it looks really ripe under one illumination, then you go somewhere else where it's darker and suddenly it looks like it's not ripe at all. Right? You want objects to maintain the same color, to have color constancy, regardless of the light you're looking at them in. Regardless of whether it's really bright, regardless of whether it's really dark, regardless of whether there's a bright red light that is shining on everything. So your brain uses information from the context to modify the actual colors that are out there. Usually, again, this is very adaptive. And as I said, it's something we refer to as color constancy.